What's happening, dogs? Mr. Allen here with a problem involving tangents of circles. So in circle C, we have AC is 18, AE is 8. We want to find AB and AD. And then it says any lines that appear to be tangent are tangent to circle C. That's one way that they phrase it into these problems here. They might just say that AB is tangent to circle C at point B, or they'll just say anything that appears to be tangent is in fact tangent, and then you can assume that, all right? So obviously it's not tangent here, it's going through, but it is tangent at D and at B. All right, cool. Now the nice thing about tangents is they come with some little special properties that we're going to be using here in a moment, all right? So first off, though, I'm going to label my diagram. I've got AC, the entire thing here is 18. I will do this. I'll do fancy, actually, maybe I'll just write it out here. So we'll do 18, all right? So that's AC. It's hard to label the whole long one. You could do some, sort of kind of brackets like that. Yeah, that'll work. All right. And then we've got AE is 8. So that's just this little guy right here. And that would leave me with EC being 10, right? Maybe we'll just go ahead and label that. I don't know if I'm going to need it, right? But might as well do it so that we get the two pieces of that puzzle. And I want to find out what AB is and AD. I don't know, right? I don't really have a way of figuring that out right now. Perhaps I need to draw in some segments. So a common thing with circles here is you're going to be drawing in some lines, segments from time to time. A good way to start is drawing in a radius, okay? You could possibly need to draw in some chords here and there, but it's not as common. Like connecting B and E here, I'm only going to get a new segment. I don't really know anything about it. But if I do draw in B to C here, okay, or C to D, it really doesn't matter. We'll see in just a moment here. If I draw this in, I know that a radius drawn to the point of tangency is then a right angle. That radius is going to be perpendicular to that ray that we have right there, AB. So that's pretty cool because I get a right triangle out of the deal, right? The same thing would happen here. I can draw that in if we'd like, because I guess we do have to find AD anyways. So draw that guy in. Boom, also a right angle. So we get two right triangles here, okay? 2 for the price of 1. Now, what else can I do with that? Well, EC is 10, right? That's a radius. And all radii in a circle are going to be the same measure. They're all going to be congruent. So those are both 10 as well. So the 10 did actually come in handy there, which is wonderful. And now I have two sides of a right triangle, which means I can solve for the third here. I'll call this X right now because that's going to be our goal, okay? So I have, let's see, the hypotenuse right across on the right angle of this right triangle and a leg. So we're going to have ourselves x squared plus 10 squared equals 18 squared. Cool. This is not a Pythagorean triple. Most of them, a lot of them are in these situations. I opted for not a Pythagorean triple in this one, which is cool. That's fine. All right, so we got x squared plus 100 equals 324. We're going to subtract 100, so I get x squared equals 224. And now I'm going to square root. All right, now you can either do a decimal or usually in a math class, we're going to have you guys break these things down using prime factors, okay? So if I divide this by 2, I'm going to end up getting, what, 112? And then if I divide by 2 again, I'll get, what, 56? Yeah, 56. Uh-oh, I'm running into the triangle here. We got 2 and what is that going to be? 28? 28. Ah! Then we got ourselves 2 and 14. Oh, we got a whole lot of 2s. We got 2 and 7. There we go. We're out. We're done. Okay. So you got it broken down to prime factors. I like to start with 2s and work my way down. If you ever catch a perfect square in there or think to divide by a perfect square, that can be a quicker way to do it, but not everybody thinks like that. So I usually like to just break it down to prime factors as it's a more consistent method, okay? So we've got a group of 2s, or a pair of 2s. So that comes out as 2 times 2, which is 4. And then the pairs that were ones that don't have pairs, the 2 and the 7, get multiplied back together, and I get 14. And you can actually check this out, okay, in my calculator. I got it buried over here somewhere. We've got the square root of 224, okay? So square root of 224. If I plug that in, I get 14.966. So we'll say 14.97. And then if I were to do 4 times the square root of 14, right, just to double check my work, right, I get the same decimal answer. I get 14.9666, right? So same answer. We can see that we properly simplified it. And guess what? If it's a multiple choice test and you forget how to do this, you could always check the decimal equivalents of them to see if you got it right. You know what I mean? Or to find the right answer in that case. Okay, so that would be what we get for what was it? AB, right? That was AB. So AB equals 4 root 14. Now, check it out. We have a hypotenuse of 18 and a leg of 10. Isn't AD going to be the exact same thing? And it absolutely will be. There's actually a two-tangent theorem that states that if you have two tangents that are drawn to the same external point A right here, then those two tangents are going to be congruent to each other. No matter where A is, anywhere I move this, if these two are tangent to the circle, then those two segments are going to be congruent. You get a lot of congruent stuff, right angles, and all those sorts of things here within circles. So look for those types of properties. And if you're just kind of looking, trying to guess or something like that, you might be able to, get lucky on getting some congruent segments or some right angles if you're kind of lost in the sauce on a circle problem. But there we go. We got ourselves 4 root 14 for our missing segments. Both of them are the same measure. That's dope. And have a great day, guys.